Okay, everyone. So this is Xinqing Xiao from China Agricultural University, and I'm from the College of Engineering. So it's my honor to join the conference on mechatronics and also smart system. So this conference is really important conference about the mechanisms and automation, robotics, and also electronics and sensors, smart systems. So the topic about today, I will introduce about the battery-free wireless sensing for the monitoring. So I will first introduce myself. I'm now a associate professor in College of Engineering, China Agricultural University, and I have also got the post Ph.D. in College of Information and Electrical Engineering in China Agricultural University. And now the research topic and is more about the smart sensing. For example, the flexible vessel, battery, self-powered, and energy harvesting, smart sensing for food monitoring, and also for smart agricultural monitoring. So another research topic is about the Internet of Things. So as we know, the Internet of Things is also a very hot and also very interesting areas. So it's also have a value for the smart system. So as we know, the food, we have many food in our daily life. For example, the fruits, vegetables, fish, and also meat. So these food, they have the key factor about the quality and safety is that they are fresh, and also they are fresh, perishable. So it's easy to have a bad. So if they have a long time to not a good store environment, and also they will have many issues to the quality and safety. So to reduce the waste and also to guarantee and ensure the food quality and safety, we need to use the important means and important ways. For example, the cold chain method. Those cold chain for food is an important means to reduce the waste, especially for the food products. For example, agricultural products. So it's an important means. So what is the cold chain logistic? As we all know, the cold chain logistics could ensure the food products could keep them stored in a low temperature environment all the time, and they could realize the method by using the artificial refrigeration technology. So you can see the picture. We could see many refrigerator truck and also the cold storage in our supermarket in the many different places. So the food, fresh food, fruit, and also vegetables, meat, and also fish, aquatic products, they will could use the low temperature storage technology to keep them all stay in a low temperature environment. So this is a cold chain logistic, so we can use in our daily life. So for the cold chain, we can know that from the planting place, we can have a processing, and we can have then packing them in a box and loading them by the forklift to the truck, and also to have a cold storage. So maybe picking and packing in the manufacturing plant, and then by the ordinary transportation to the cold storage. So then we are go to the cold chain storage. For example, they may be unloading by the forklift and then pre-cooling and then get into the warehouse. Then we have a solid time. This time we will keep them in a low temperature. And then we will have all the time in the warehouse. Then if they want to get out, then we can have a loading by the forklift and to the truck. So To the refrigerated transportation, they could buy them to use in the market sales. So they could use the transportation by the refrigerating truck. And then they can go to the market share. For example, they can storage in the supermarket, and you can know that all the time they are in a low temperature. So this is many processes for the cold chain storage, cold chain supply chain, and cold chain storage, transportation, and also sales. So during the time, so we can that cold chain is very conflict. For example, they have storage, cold storage, just the refrigeration truck. So it's has many complex environments. And they also have the information asymmetry. The information asymmetry is very high, so that you can not you can not easy to get the transportation information about the food quality in the cold chain. So this is a difficult things for got the transportation information during the cold chain. So we need to use some innovation method to get the temperature and relative humidity or maybe other environmental factors. So during the cold chain, we know the temperature and the relative humidity are the main factors that affect the product's quality and safety. So also we have many other factors for the gas, magnet B, and also many other parameters. For example, in the supermarket, we have the meat to get the low temperature, the fruits in the cold refrigeration, and also the fruits, vegetables. So they have many different kinds of the parameters that could affect the quality and safety. So we need to conduct intelligent monitoring technology for cold chain logic to complete the data acquisition, processing, and environment control. So the usually we have for example, temperature and humidity recorder, and also the RFID, and also the wireless sensor network. So this method could be used for improved food quality and transparency in the food cold chain, and we can realize the monitoring of the food quality. The wireless sensor network is not have used in most time in the food cold chain, so it's a good technology, and it's also belong to the Internet of Things, one of the Internet of Things technology. So the wireless sensor network could sense and collect the sensor data, for example, the temperature, relative humidity, and maybe gas sensor data, and send them to end users via wireless and also multi-hop network. So you can see from the picture, they have many sensor nodes and also have the remote sensor and also the coordinator nodes and the sensors. So it has the advantage to the locals mobility, flexibility, fast movement, and also special occasion usage. So they are widely used in the food culture. But so we have this is the example. So we have used before for development the wireless sensor network system for monitoring the cold chain transportation, cold chain storage by the sensor nodes, and also we have a network coordinator for managing all the networks to get the sensor data, for example, temperature and also relative humidity, and then we can change them to the remote sensor by the remote wireless sensors networks by the for example DBS, 3 generation, and also 5G, 4G, these remote wireless communication technologies. And then the data could be used for in the database and also for another, for example, the data display and also data processing may be used for different kinds of things for display, for history, storage, and so we can analyze the data in the remote sensor. This is we have used the temperature and humidity sensors and also some gas sensors, for example, the precision gas, sulfur dioxide, and also we can use the oxygen sensor and also carbon dioxide sensors. But in wide sensor network, there are many sensors. But in our usual application, we have noticed that there are many batteries are needed for the power supply for each wide sensor node. So if there is no any battery for the power, the sensor nodes will not work. So this is a big problem during the subtrain and also cold chain, especially in the cold storage, refrigeration truck, transportation. So this is a big problem so that the energy of the batteries, if you want to get the data continuous and also will not interrupt the batteries, will need to manually place. So this battery is limited. Once the battery is exhausted, the data will interrupt. So it will not a continuous monitoring things. So to solve this problem, we have a new technology for battery-free sensing. Battery-free sensing is one of the most promising ways to cold chain temperature monitoring with a battery's limitation compared with conventional wide sensor network. For example, in the picture, so it could realize the dynamic sensor data acquisition from a reader to several battery sensing tags. So no battery could be used in the tags. It just need a reader, and we don't need to have a battery replace. So it was easy and also very flexible to use for the food chain. So now there are two kinds of the battery freezing technologies. One is the near-field communication technology, and another is radio frequency identification technology. As we know, one is FC and one is FID. So these two kinds is now has many applications in our daily life. But it also could used for our food monitoring by the battery sensing, by combine the different kind of sensors. So we can use the battery wide sensing to realize more food monitoring in real time. So if we want to use them to get the idea for monitoring of the food quality and safety in cold chain or in supply chain, so we need the dynamic sensors. So NFC or RFID with dynamic sensors could integrate the different sensors for realizing real-time acquired dynamic sensor and conventional static data. For example, temperature, gas, relative humidity in the environment of the cold storage or refrigeration transportation. They have always used, for example, different kinds of the NFC or UHF with dynamic sensors. One is for the short distance and one is the long distance. They have different kinds of the bands and frequencies, and also they have different range. So if you want to get a long range about the transmission of the data, so we can use the UHF, and also if we don't need a long range, so we can use the FC or use the FID. So this is, for example for our research work about the battery wide sensor system with complete sensing for typograph cold chain. So this is use the UHF RFID, so they could be used for the temperature monitoring. This monitoring could use the SL2900A and also use the RFID reader. So it's a simple tag. It could not another battery to use. They can got the temperature in the from the typograph packing and storage and spray cooling and also transportation, all the supply chain process. And we can got the temperature from harvest, pre-cooling, storage, loading, and transportation, and then for sale. It's a long distance for supply chain. So it's also easy to deploy them in the implementation of the supply chain. So this is another research work about we have used a flag pH sensor system for the fish monitoring. So also we use RFID and also is about 13.56 about the frequency. The pH sensors we have used in the battery sensor tag. So we can by using the RFID antenna to get the pH sensor data, and then it has also could used for the power in the check. They don't need to the battery to get the data, and then the RFID reader could also transfer them to the computer, PC, and also maybe the surface. So this is, for example, the pH sensor. We have used flexible pH sensors, and we have used the flexible reader to get the sensor data. And we have example use the pH sensor to get the fish meat. So we have meet the pH sensors from the fish and then got the data and by the RFID technology. So it's an easy way to get the pH data without the battery. So it's a battery-free wet sensor method. So you can get the results so that we can see that it has a good linear fishing for the pH data, and it could be used for indicating the fish quality and also got the wet sensing data. So it's a flexible battery-free pH sensor system for the fish monitoring. Another research work about battery-free wet moisture sensor system for fruit monitoring. So it's the same as before. We can use also the FC method technology to get the weighing sensors and temperature sensors. So this work we have got two kinds of the sensor data. One is the temperature, one is the weighing. So they have a microcontroller and also use the NX harvester and have a frequency for the 13.56. And we can use our mobile phone with NFC enabled device to get the data in real time. And it's easy hardware, so as shown in our pictures. It's have a NFC antenna and also temperature sensor and also have NFC chip and macro sensor and microcontroller chip and also have a sensor interface. So it could be used for monitoring the fruit moisture. So the moisture is about the weighing. So when they have a long time storage, they will have reduced the moisture in the fruit. So it's a good thing to real time get the moisture sensor system. Then we have used the flexible battery wet electron system for food monitoring. So this is a general battery wet electronic system. For example, we can also got the temperature sensor, weighing sensor, and also pH sensors. So these sensors could be used for the same as the before. We have the food sensors, and we have used the FCA communication, and we can make them flexible, so it could be used for fruits, used for fish, and also can communicate by our smartphone and by also maybe smart apps reader. So it all could be used. So we have used this method to make the flexible electronic circuit. This is a laser direct clamping method. So we have used the laser to create the circuit, and then we have used the temperature sensors to get the cold chain temperature in different temperature, for example, in 0 centigrade and also below 18 centigrade. So we have used this time to get the real-time temperature. And also we can use them to react to moisture sensors, just like the research work before we have introduced. So it also could be used for monitoring the moisture in the fruit. So it could be easy to deploy them and also connect them and communicate them by the battery sensing system. And we also could be used to realize the monitoring about the pH in the fish meat. So it could easy to get the battery pH sensors, and also like the work before we have introduced is a pH monitoring system. So this flexible battery wireless education system is easy to be used different kinds of food monitoring. So this is all the work we have researched. So in the future, I think maybe the battery could be a promising ways to realize the food quality. So if we could be used, for example, use the flexible sensing, non-teacher sensing, and also web sensing technology, and also if we could combine the AI technology, so we maybe have a more smart system for the food monitoring. So this need to further development and also need to combine them together. So it will be maybe a huge promising way to realize food quality and realize the food monitoring in the future. So this is a bright future, I think. Okay, so this is about the topic about the reputation we have shared. Okay, thank you.